In this video, we're going to calculate surface area of prisms and cylinders. So the lateral area, this is the area of the sides of a 3D figure. Here's our 3D figure. The corner right here, this is a vertex. This piece that's shaded here is a face. The edge runs vertically, it's this guy right here. We also have an edge down here and right here. These are all edges. And the base, we looked at this in the last video, that's on the bottom. That you'll have two of, and so you'll see that we've got another base up here. To find the surface area, it is the sum of all the areas of all the shapes that cover the surface of the figure. Here are some different prisms, and we know from the last video that a prism is a solid object with two identical, or we can say congruent, flat bases. So we have two flat bases, and so in each of these there's one, these are the bases, here's the base here. The base on this one, it's going to be this back trapezoid and this front trapezoid. Those are the two congruent bases. And on this hexagonal prism, of course, the hexagon on the bottom and the top. LA stands for the lateral area. Okay, so this is the area of all the sides, and it is calculated with perimeter times height of the figure. SA, this is total surface area. And that is, well, the lateral area plus the area of the two bases. So this is the area of the base. And since it's a prism, it's got two of them. So that's why you multiply by the two. P is the perimeter, and H is the height. All right, let's take a look at some examples. Excuse me. Okay, so first thing, we're going to find the lateral area and the surface, the total surface area. So the lateral area is going to be, well, the perimeter of the base. Okay, so our base is this triangle, and we have two of them. We have one on the top and we have one on the bottom. But I'm just going to look at this one. Do you see this little guy in the corner? That's your right angle. So what we need to do is we're missing this length on the left. Since this is a right triangle, we can use Pythagorean theorem. And so let's see, x squared plus this distance here is the same as this 7 here. So 7 squared is equal to 25 squared. That's across the box. This is our hypotenuse, our C value. All right, and this is just our Pythagorean theorem. If I work this out, let's see, x squared is equal to, 625 squared is 625, and 7 squared is 49. If I subtract that, x is going to equal the square root of 576. If I subtract 49 from 625 and then take the square root, it's going to be 576. And x is equal to 24. Okay, so now I can figure out what my perimeter is. The perimeter is adding up these three side lengths. So 24 plus 7 plus 25. Let's see, that's going to be 49 plus 7 and 56. So that's the perimeter. Okay, the height of my figure, that is this guy. All right, and so if I want to find the lateral area, it's going to be the perimeter times the height. And when I multiply these together, that gives me 448. And let's see, my units are meters, and area is meters squared. So that's my lateral area. Now, to find the surface area, I need to find the area of the base. And we know that the base is the triangle. And so that's area is 1/2 base times height. And so 1/2, 7 times 24. And if we calculate that, let's see, half of 24 is 12 times 7, and that's 84. So this base area is 84. Okay, so now we have the surface area. There's a lot of calculations. Okay, so surface area is lateral plus 2 of the bases. And if we calculate that, 2 times 84 is 168 plus 448. The total surface area is 616 meters squared. Okay, in number 2, we have a hexagonal prism. So we know that the base is a hexagon. And each of, I'm going to go ahead and work with this one on the bottom. And I'm going to pick up my black. Okay, so the area is 1/2 apothem times perimeter. We can't forget that. So the perimeter of that base is, well, if each of the sides is 6, and we have 6 of them, it's going to be 36. Okay, and so let's go ahead and draw in just like we did in our last unit. And hopefully you recall that one of these angles, these vertex angles, is 120 degrees. And so if I cut this guy in half, I'm looking at this right triangle that has a 60 degree. Of course, you've got the 30 at the top. Now, if one side length is 6, then half of this guy is 3. So this piece is 3. And if we recall our 30, 60, 90 rules, this is x, x root 3, and 2x. Across from the 30 is equal to the x value, so that would be 3. This would be 3 roots 3, which is the apothem. Okay, so now I can figure out the area of this base. So my area is 1/2 3 roots 3 times the perimeter. And we already said that the perimeter was 36. Now, I've already done the calculations on this. Half of 36 is what, 18 times 3? And that's 54 roots 3. And that's the area of that base. Okay, so the lateral area, I guess let's go ahead and do that. The lateral area is equal to the perimeter times the height, and so that's just 360. The height of the figure is this guy right here. This is your h, and we already said that the perimeter was 36, so that gives us 360 feet squared. Now the total surface area is the lateral plus 2 of the bases, and each of those bases is 54 roots 3. Excuse me. So let's see. Okay, so it is equal to the lateral plus twice the bases. And let's see, if I put this into my calculator, this is going to equal 547.06 feet, and the units is squared. So 547.06 feet squared. All right, our third example. It says we have a right prism with a base that is an isosceles trapezoid. Okay, so we can see our base here. This is our isosceles trapezoid. We have one in the front and one in the back. All right, the bases are 8 and 16. So I'm going to go ahead and draw this isosceles trapezoid. This guy's 8, this guy's 16. What I can do is I will drop that down, and instead of writing 16 there, I'm going to call this 8 and 4 and 4, so that I just can separate out those measurements. That still adds up to 16. And the legs are 5, so each of these sides is 5. The height of the prism is 15. All right, so my lateral area is the perimeter times the height. And so if I add up the perimeter here, the perimeter is 16 plus 8 plus 2 times 5. All right, so 16 and 8 is 24 plus 10 is 34. That's my perimeter. All right, and then my height is 15, so my lateral area is equal to 34 times 15. And if I calculate that, that gives me 510, and I don't have any units, so I'm just going to say units squared. Now, I need to figure out the area of my base to find my surface area. So area of a trapezoid, this is your formula. This is your trapezoid area. All right, so what we're going to do is 1/2 base 1 plus base 2 times the height. So we know that the two bases are 8 and 16, and the height, oh, I don't know the height. The height is the vertical. So you know what I'm going to do? I'm going to highlight, I don't know, in yellow. That is this piece right here. But that we should recognize. I don't like yellow. I'm going to go ahead and, okay, these numbers 4 and 5, this is on a right triangle. Hopefully you recognize this is a Pythagorean triple. That height is going to be 3. Okay, so we can get back to work here. 8 and 16 is 24. Half of 24 is 12 times 3. And what is that? 12 times 3 is 36. So the area of one of my trapezoids, my base, is 36. All right, so now surface area is the lateral, which is 510, plus 2 times the bases. So that's 72 plus 510, and that is going to give you 582 units squared. All right, let's take a look at a cylinder. The lateral surface area on a cylinder. Okay, so that's this side right here, okay, or this side right here. That's the lateral surface area. And we can see that around, that is just your circumference of a circle. And so the area of the circumference, or the formula for the circumference of a circle is 2 pi r. If I want the lateral, then I just need to go ahead and add on to the height. And so this is going to be 2 pi r times h. For the surface area, it's 2 pi r times h plus twice the bases. And in this case, our bases are circles, so that is 2 times pi r squared. All right, so here's some examples. And in this time, it wants us just to leave in terms of pi, so we don't have to get a decimal answer. Okay, so, oh, and also, by the way, R stands for radius. And the reason I mention that is because you're given the diameter in this case. So we know that the diameter is 24, the radius is going to be 12. Okay, and of course we can see that the height is this vertical, and that's 30. All right, so first up is the lateral area, which is 2 pi r times 30. All right, so if we multiply 2 times 12 is 24, times 30 is going to give me 720, and I'll just leave the pi, and that's units, inches in this case. And then the surface area is going to be, well, 720 pi plus 2 times the area of the base. And the area of a circle is pi r squared. So 2 times pi times the radius squared. All right, and if we figure this as 12 squared is 144 times 2 is 288. So 288 pi plus 720 pi is 1,008 pi inches squared. And the last one, find the height of a cylinder whose lateral area, so I'm just going to go ahead and write down the formula, 2 pi RH is 90 pi millimeters squared, and the radius is 5. And so we're just solving for h. We're just trying to find the height. Okay, so let's see. I've got 90 pi, and then if I multiply the 2 and the 5, that gives me 10 pi. And if I divide both sides by 10 pi, h is going to equal 9. So the height is going to be 9 millimeters.